Hi everyone, this is Dr. Sandeep, working as Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about the atomic structure and bonding in solids. So coming to the definition of the atomic structure. So what is the atomic structure? So this atomic structure refers to the structure of an atom comprising of nucleus in which you have protons and neutrons. So, atomic structure is a structure of atoms which is comprising of the protons and neutrons. So, what are the protons here? Protons are which are positively charged. So, the protons which are positively charged and neutrons are neutral. And the negatively charged particles are called as electrons. So, this is the complete structure of an atom. So, atomic structure is nothing but the combination of electrons, protons, and the nucleus. Now, how are the arrangements of these protons, electrons, and neutrons? We'll see in the figure. If you see here, it is the complete set in which you have a proton as well as neutrons. So, protons, you can see here, this is the orange symbol, that is the protons, which is having the positive charge. And if you see the blue color, these are called the neutrons, which is having a neutral charge. Okay. And the electrons, what are the electrons we have here? These are all negatively charged, okay, which revolves around this nucleus. So we have the complete nucleus here. Around the nucleus, you have the negatively charged electrons which revolve. And this orbit, in which orbit it is revolving, means electron orbit. On electron orbit, the electrons are being revolving. Okay, and this nucleus is composed of protons and neutrons. The protons are positively charged and the neutrons are a neutral charge. So this is the complete structure of the atom. So the atomic structure refers to the structure of atoms which is containing of the protons as well as neutrons. The protons are the positively charged and the neutrons are neutral charged, whereas the electrons which are negatively charged. The atomic structure of an element refers to the constitution of its nucleus and the arrangement of electrons around it. So, the complete atomic structure of an element which is referred to the constitution of these nucleus which is arranged of the electrons in it. So, the arrangement, if you see here, the complete nucleus is the constitution of the arrangement of electrons. So, these are the electrons which are revolving around the nucleus. So, primarily the atomic structure of matter is made up of protons, electrons, and neutrons. The complete set of all these, the protons, electrons, and neutrons, refers to the complete atomic structure of the nucleus. Okay, the nucleus is composed of all these three atoms: the positive atoms, negative atoms, as well as the neutral atoms. The protons and neutrons make up the nucleus of the atom. So what is happening here? The protons as well as the neutrons are making up the nucleus of the atom, which is surrounded by the electrons. So first you have the protons, then the neutrons, and these two are surrounded by the electrons. So this is how you have the atomic structure. And the atomic number of an element describes the total number of protons in it. So if you want to find out the total number of protons in the atomic structure, so how can you find this? Based upon the atomic number. So if you know the atomic number, then it is very easy for us to find out the number of protons present in the nucleus. So that is how you can easily find out the atomic number based upon the number of protons available in the nucleus. So this nucleus is having the neutrons as well as the protons, and these are surrounded by the electrons. So this is the complete structure of the atom. So this is the nucleus what we have. In this nucleus we have the protons as well as the electrons. So these are the protons, the orange balls, the orange atoms, and the blue are the neutron. So this proton has a positive charge and the neutrons has the neutral charge, and this is about the nucleus. And around the nucleus you have the electrons. So if you see these electrons, these are the around the nucleus you have. So the complete proton and neutrons refers to the nucleus, and the electrons are negatively charged. Negatively charged. And how these electrons are traveling means based upon the orbit, electron orbit you have. So with the reference of this electron orbit, the electrons are being revolving around the nucleus, which is composed of both neutrons as well as the protons. So atomic structure, if you see again, neutral atoms have equal number of protons and electrons. So what is happening here? What are the nucleus we have, which is composed of the protons as well as the electrons. So these are having a neutral. So since it is a neutral atom, so what we have to do, it has to be balanced. That's why the number of protons as well as electrons which are having in the neutral are equal to each other. And however, the atoms might gain or lose electrons in order to increase the stability and resulting the charged entity which is called as an ion. So in order to increase the stability of the atom, this atom can gain or lose the electrons. Okay, in order to get the more stability of the atom, it can release or it can take, okay, the electrons to enhance the stability as well as resulting in the charged entity. So there is some change in the charge, is it not? When you're giving something, so the charge will change either from positive to negative or negative to positive. So that is the change when you give any atom. So there is a change in the entity, charge entity. So this type of thing is called as an ion. So what is an ion? Well, an atom which is losing or gaining the electrons in order to increase the stability, then that type of thing is called as an ion. Okay, so this ion refers to again the change in the charge entity. So atoms of different elements have different atomic structure because they contain different number of protons and electrons. So each atom has its own atomic structure. Why? Because again each atom has its own number of protons and number of electrons. So based upon this number of electrons and number of protons, the atomic structure of the atom will vary for each type of atom. So this is the reason, that's why you have the unique characteristics of different elements. So how you are differentiating the characteristics of each element means based upon the atomic structure, and how this atomic structure is being developing means based upon the number of protons or number of electrons present in the atom. So that's why you can easily differentiate or you can easily characterize each atom based upon the number of protons or electrons present in it. So that is the atomic structure, how it is being varying, and this is different from each element. Each element or each atom has its own atomic structure. And why it is very important to study the interatomic bonding. So what is the importance of this interatomic bonding? If you see here, we have an important reason to have an understanding of interatomic bonding in solids. Why means in order to get the type of bonding, what type of bonding you have, and depending upon the bonding, it is very easy for us to explain the material properties. Okay, once if you know what type of bonding, whether it is a primary bonding or secondary bonding, so based upon the bonding we can easily find out the atomic structure, as well as based upon that atomic structure it is very easy for us to characterize the material or to bring out the properties of the material. And there are different types of bonding here. You have the primary bonding as well as secondary bonding. So we'll see what are the different types again in the primary as well as the secondary bonding. So if you see the in the primary bonding, the first one you have the covalent bond, ionic bond as well as metallic bond. So three types of bonds are available in the primary bonding: ionic bond, covalent bond and metallic bond. So these are the categories you have in the primary bonding. So what is happening here? For each type, the bonding is necessary involves the valence electrons. So any type of bonding, if you consider from the three, ionic or metallic or covalent bond, it has to have necessary involves the valence electrons. So once if you have the valence electrons, then only the bonding will be there between the atoms, is it not? So that's why the nature of the bond depends on the electron structure of the constituent atoms. So what type of bond you have? So this bond will completely depend upon the electronic structure of the constituent atom, whatever the atom we are taking. So okay, the type of bonding it completely depends upon the atomic structure or the electronic structure. So in generally, what happens here? Each of these three types of bonding, what we have discussed, ionic or covalent or the metallic bonding, have the tendency of the atoms to assume stable electron structure. So we have to assume that these three types of bonding, from the three types of primary bonding, it has to be stable electronic structure, and those has inert gases, and by completely filling the outer shell, okay, outer shell of the electron. So this is the considerations you have to take into picture while finding the bonding, what type of bonding we have in the atoms. And the secondary or physical forces and energies are also found in many solid materials. This is not, we can see not only the primary, we can see also the any other secondary forces which are involving on the solid materials. So what happens because of these secondary forces which are involving on the atoms? So there is again slight weaker in the primary ones, and this also influence the physical as well as the mechanical properties of the materials. And we'll see each one type of bonding here. So first, primary interatomic bonding you have as a ionic bonding. So ionic bonding is the easiest way to describe and visualize. Why? Because we'll see how it is being identified, what type of bonding it is. So it is always found in compounds that are composed of both metallic as well as non-metallic elements, which are suited at the horizontal extremities of the periodic table. So this type of ionic bonding we can find in compounds which are composed of both metallic as well as the non-metallic elements, and these are suitably existing at the horizontal extremities of your periodic table. And atoms of metallic element easily give up their valence electrons to the non-metallic atoms. So what are the atoms we have here? So from the metallic elements, they give easily their valence electrons which is surrounding on the orbit of the atom. So thus you can easily share the electrons based upon the charge you have. So ionic bond is also called as a electrovalent bond. So another name for the ionic bond is nothing but the electrovalent bond. This type of linkage formed from the electrostatic attraction between the positive charged ion and the chemical compound. So why you are getting this electrovalent means because of the difference in the charge, whether it is a positive or negative. Okay, if you have two different charges, then there is a easy attraction of the atoms. So that is why it is called as ionic. So there is a strong bond when you have two different or two opposite poles. Since two opposite poles attract very strong to each other, that's why the arrangement of this ionic bond, it should be in a way that there should be a positive, negative, positive, negative. So in this sequence, you have to arrange the atoms in different charges. So that's why there is a strong bonding in the ionic bonding, since there is a lot of attraction between your positive as well as the negative chemical compound. So such a bond forms from the valence, that is the outermost electrons of one atom, and is transferred permanently to another. So because of the outer shell, atoms have outer shell, on the outer shell we have different atoms. So because of the two different charged particles are there, so there is a complete attraction between them. So thus there is a permanent transfer of the atom to another atom. So because of that, what is happening here? The atom that loses the electron becomes a positive charge. So that is called as a cation. So what is cation? Which are losing the electrons. Those are called the cations. And while that gains, those type of things are called as anion. Okay, so whatever the atoms or electrons we are giving, then that type of thing is called cation, which is losing, and which is gaining is called as a anion. Ionic bonding results in compounds known as ionic or electrovalent. So we have the two names, ionic or electrovalent bonding, which is the best exemplified by the compounds formed between the non-metal and metallic elements. So in ionic crystallization, solids of this kind, the electrostatic force of attraction between the opposite charge. So there is a huge electrostatic force of attraction when there is a different charges. So if you have the same charges, there is no attraction between the atoms. So always the arrangement should be in such a way that there is a almost always opposite charges. Whether it is a positive, then you have to arrange in negative. So because of these opposite charges, there is a lot of electrostatic force of attraction between these charges, and thus you have a strong bonding between the atoms. And of course you have a repulsion when you have the similar charges. So here if you have an opposite charge, you have a strong attraction force, and if you have a similar charges, then there is a repulsion. So in such a way that you have to arrange your atoms if you want to have a strong bonding between the atoms. So if you want to have strong bonding, then it should be opposite charge. If you want to repel, it should be the same charge. So that is the thing you have to logically apply. And ions are arranged in such a way that positive and negative charges are alternatively arranged and balance one another. So in order to achieve this ionic bonding, you have to arrange the ions in such a way that there should be a positive and negative. So this should be done alternatively so that there is a strong between them, and the overall charge of the entire substance should be zero. Why? Because you are trying to balance these two. You're balancing by arranging the both the charges in alternately with positive negative and positive negative. So thus you will get the balance, and total charge of the entire substance should be being zero because you're balancing everything. And the magnitude of the electrostatic force in ionic crystals is considerably, and according to that substance you need to have the hardened non-volatile substance. And this is how you are arranging. If you see here, if you compare this sodium chloride, you have the positive charge of sodium, and again you have the chloride as a negative. So what is happening here, because of the positive and negative charges arranged like this side by side, there is a lot of attraction between the force of attraction between these two, and you have a strong bond. Sodium chloride you're getting. So sodium and chloride separately you have, and since these two atoms are arranged in such a way that there is a opposite charge, so because of this opposite charge, there is a lot of force of attraction between these two, and you're getting a combined thing of NaCl, that is sodium chloride. So everywhere if you see positive negative positive negative and positive negative, in this direction if you see, in this direction if you see, in this direction if you see, and in this direction, so any direction if you see, all the directions are equally arranged in such a way that there is a lot of force of attraction between them, in such a way that you are arranging a positive negative alternatively and trying to bring out the total forces as zero. Why? Because you are balancing them by arranging this alternative method. And sodium chloride is the best example to explain about this ionic bonding. And the sodium atom has a single electron in the outermost shell. So in the outermost shell of the sodium, you have the single electron. This is trying to combine with the chloride, which is having a negative on the outer shell. So though these two will get attraction between the positive of sodium and the negative of chloride, and get the ionic bonding between these two. So that is how you have the ionic bonding with arrangement of charges in opposite directions. And coming to the second bonding in the primary, you have the covalent bond. So covalent bond stable electron configuration are assumed by the sharing of electrons between adjacent atoms. So what is happening here? You are trying to share the atoms between the adjacent. So in the ionic bonding, we are trying to arrange them in a different signs, whether it is positive or negative. But in this covalent bond, it is trying to share between the adjacent atoms, and it looks like a single. So two atoms that are covalently bonded will each contribute at least one electron to the bond, and the same shared electron may be considered to belong to both the atoms. So what is happening? What are the outer shell we have? So here you can have and here also you can have some 3. Now the outer shell of this atom can be shared with this, and it look like, now you can get here and one more here. So totally initially you have here 4. Now if you count how much you will have, see, now it will be combined like this: 1, 2, 3 and 4 you are getting, and 5. So here you are getting 5. Initially it was 4. Now since it is being sharing with this, you are getting 5 here, and initially it was 3. Now if you count 1, 2, 3 and 4. So initially it was 4 and now you are getting 5. Initially it was 3 and you are getting 4. So like that, it is sharing the electrons to the adjacent. Now you can see the clear example here. The covalent bonding can be explained with the help of this methane, how this is happening. The carbon atom has 4 valence electrons. If we see here, this is the carbon atom. In the outer shell, this is the outer shell. This is the outer shell of the carbon, and it is having how many? Total 4 valence electrons. 1, 2, 3 and 4. So totally 4 valence electrons are there on the outer shell of the carbon. And if you see the hydrogen atom acquire helium configuration, this is having again 1, 2, 3 and 4. Hydrogen is having 4. Now since the covalent bond is being happening with the sharing of the electrons to the adjacent, so this carbon is being shared with the hydrogen atoms. So if you share, see here, shared electron from hydrogen and shared electron from carbon. So it is sharing the electrons from the carbon as well as the hydrogen. Now if you see combinedly how many things you are having, the carbon now has 4 additional shared electrons. Initially the carbon has only 4. Now the hydrogen is sharing another 4. So 4 plus 4 totally you will have 8. So that's why the carbon now has 4 additional shared electrons, 1 from each hydrogen. So 1 from each hydrogen, you are sharing total 4 electrons to the carbon. So totally you will get the 8. So the covalent bond is directional. This is the between the specific atoms and may exist in the direction between one atom and another that participate in the electron sharing. So this is how you will get the covalent bond, by sharing of electrons from one another, adjacent sharing. So you have another examples of these covalent bond, many non-metallic elements like H2, Cl2, F2, etc. These are some of the types of covalent bond you have, and also molecules with containing dissimilar atoms such as CH4, H2O, HNO3 and HF. These are also covalently bond. So these are some of the examples where you can see the type of covalent. And in case of ionic bond, you can see the sodium chloride, sodium carbonate, all these things comes under the ionic bond. So that is the main difference between the ionic as well as the covalent bond. And if you see this further for this covalent bond, what is happening because of the sharing, this type of bonding is found in elemental solids such as diamond, silicon, germanium and other solid compounds composed of elements which are located at the right hand side of your periodic table. So if you understand the complete picture of the periodic table, then it is very easy for us to identify what type of elements are having what type of bonding. So based upon the bonding also, you can easily find out what are the properties. So why we are studying all this atomic structure, what type of bonding in the elements means. So these are influencing the properties of the material. So once if you know the basic thing which is happening inside the material, how the neutrons or how the atoms or how the atomic structure is inside, then it is very easy for us to know what type of properties are varying and what are the properties of the metal we can easily identify. And coming to the third bonding, in the primary bonding, we have the metallic bonding. So this metallic bonding is the final primary bonding type which is found in metals and their alloys. So where you can see this type of metal bonding means you can see in the metals and their alloys. And a relatively simple mode has been proposed to explain this type of bonding scheme. So metallic materials have 1 or 2 or mostly 3 valence electrons. Okay, so what are the metals we have in the periodic table? These will have 1 or 2 or 3 valence electrons on the outer shell, as we have seen for the carbon and hydrogen. The similar way, the carbon is having their 4 and hydrogen is having 1. But in this case, the metals will have 1, 2 or 3. So that is the outermost shell where we can see these electrons. And this, with this model, these valence electrons are not bound to any particular atom in the solids. Okay, so what happens here? They may be bought belonging to the metal as a whole, forming a sea of electrons. You can see the complete sea of electrons, or it is called as an electron cloud. And the remaining non-valence electrons and atomic nuclei, from which these are called as iron core. Okay, so in between you have some gaps, so that is called as a, if you see here, this is the sea of electrons where you have the empty space, and these are the iron cores. So again, these are arranged positive and negative. You can see there you get the bonding. So this is how you get the bonding in the metallic bonding. So the free electrons, where are the free electrons we have in between the positive and negative, the space which we find. So these positively charged ions are mutually repulsive electrostatic force. Again, because of the difference in the charges, there is a lot of force of attraction between these atoms or molecules, and you'll get the bonding between the elements. And these type of free electrons, what are the free electrons are present inside, so this acts as a glue. What is a glue? So the application of glue is to join the materials. In the similar way, what are the empty space we are seeing, the free electron space we are seeing, so that free electron space acts as a glue to combine the different types of atoms. And if you see the bonding energies and the melting temperature for various substances for the three types of primary bonding. So first one is the ionic bonding. If you see here, the NaCl MgO, they are the two substances which, if we consider, the bonding energy is about 640 kilojoules for sodium chloride, and the ionic molecule is 3.3, and the melting temperature is 801. And if you see the magnesium oxide, the bonding energy is about 1000 kilojoules per mole, and the melting temperature is around 2800. So like that, for the covalent, what type of bonding energy is required for silicon? It is about 450 kilojoules per mole, and the melting temperature is about 1410. Similarly, for the diamond, the bonding energy is 713, and it is the melting temperature is less than 3550 degrees centigrade. So like that, for every type of material, okay, what are the substance you have, the bonding energy, how much amount of bond energy is available, as well as the melting temperature for different types of bonding we can see. For the metallic also, if you see here, again you have four different substances you have. For these four, you have the four different bonding energy with respect to the kilojoules, as well as the melting temperatures are given as -39, 660, 1538 and 3410 degrees centigrade. So this is how you can easily find out what type of bonding energy is required for the material based upon the type of bonding, as well as what is the melting temperature. So if you know all these things, and then it is very easy for us to select the material depending upon the application, what type of material is required based upon your application. So that is about the primary bonding, the three classifications we have. And coming to the second category of the bonding, you have the secondary bonding, or it is called as van der Waals bonding. Primary bonding, you have three, and coming to this another bonding, secondary bonding, or it is sometimes it is called as a van der Waals bonding. And these type of bonding or physical bonds are weak when you compare with the primary. So when you compare the energy levels or the bonding energy levels between the primary and secondary, the secondary will have very less of weak bonding when you compare with the primary. So typically this ranges from 10 kilojoules per mole. So this is the very less energy we have in this secondary bonding. So that's why mostly the primary bonding elements only we are using in any mechanical applications. Secondary bonding existing between the virtually of all atoms or molecules, but its presence may be obscured in any of the three primary bondings which is present. The secondary bonding is evidence for the inert gases which has stable electron structure. So where you can find the secondary bonding type of things means it can be found in the inert gases. Why only inert gases means because of the stable structure, stable electronic structure. That's why we can have this type of secondary bondings. And why, in addition to this, you have the molecules intermolecular structure which has covalently bond in this type of secondary bonding. And the secondary bonding forces arises from the atomic or molecular dipoles. So how we are getting the attraction between the molecules based upon the secondary type of bonding is based upon the dipoles. So again, these dipoles should be arranged in the different charges. Again, if you arrange them in positive and negative charge, you'll have this type of bonding on the secondary bonding based upon the dipoles. So what is happening here? The electron dipoles exist whenever there is some separation of positive and negative. So always there is a force of attraction between the molecules when there is a different charges are available. So in a similar way, these dipoles, what are the dipoles we are using? The dipoles has to be arranged in such a manner that there is a separation between your positive as well as negative charges, so that there is a attraction between these molecules. So because of that, what is happening? The bonding results from the Coulombic attraction between the positive end as well as the dipole of the negative region, which is arranged adjacent like this. So if you see the figure here, these are the dipoles which is having a positive and negative, and we are arranging another dipole or molecular dipole in such a way that since it is a negative here you have to keep a positive charge. So what is happening? Because of the different charges between these two molecules, there is again the force of attraction. So this positive is trying to come here to closer and this negative is trying to come here. So there is a force of attraction between these dipoles, okay, and you are getting this type of secondary bond in this with the help of the dipoles. So dipole interaction occur between the included dipoles and polar molecules, and the hydrogen bonding, a special type of secondary bonding, is found to exist between some of the molecules that have hydrogen as one of the constants. So if you have hydrogen as a major constant, so then it is very easy for us to find out the secondary bonding based upon the dipoles. So these bonding mechanism we'll see now. Again, in this dipole system, we have different dipoles, the arrangement of the arbitrary and the arrangement of the molecules, how it is being arbitrary, we'll see now. So dipole may be created or induced in an atom or a molecule that is normally electrical symmetry. So generally, we'll get the symmetrical thing, so that there is a bonding between the different charged particles. So that is the general thing. So as you see the figure A, so this is a symmetry. This is symmetry. Then you can get easily bond between these two. Now, because of these charges, what is happening? So there is somewhat slight variation or vibrations during the motion of the arbitrary. So because of that vibrations, what is happening? Slowly the symmetrical axis, what are the symmetry we are seeing in the figure A, slowly it is changing to some different elliptical thing. So because of that, what is happening? The center atom, the center nucleus, what you are having here, that is slowly shifting to the one of the corner here. So there is a less bond. So that's why when you compare with the primary bonding, the secondary bonding, why they are weak means because of this. Because of this, the variation of the nucleus, it is coming very far away. So that's why the orientation is changing. So there is a less bond energy in this secondary bonding when you compare with the higher bonding. So this is how there is a change in the bonding energy for the secondary type of thing. That's why it is called as a fluctuating induced dipole bonds. So since because of these fluctuations, what is happening? The symmetry is changing to another shape and there is a drift in the nuclei. So that is what you are getting in the vehicle of the bonding. So one of these dipoles can in turn produce displacement of the electrons, distribution of the adjacent molecules or the atoms. So because of this unsymmetrical, so what is happening? There is a distortion or the disturbance of the electrons. So because of this disturbance of the electrons, there is again the change in the positions of the atoms inside the nucleus. So because of that, you can identify the less bonding between the atoms. So these attractive forces may exist between the large number of atoms or molecules, which forces are temporary and fluctuate within them. So because of that fluctuation or the unsymmetry, the atoms which are present inside cannot be completely bond. So these are temporarily bond to each other. So that's why you're getting a weak bond energy when you compare with the primary type of bonding. So liquefaction is some of causes, and the solidification of inert gases and other electrical neutral and symmetry molecules such as H2, Cl2 are realized because of this type of bonding. So during the solidification of the inert gases or the liquefaction of the inert gases, with examples of H2 and Cl2, these are having very less bonding. Why means because of during this liquefaction and solidification, the orientation of the nucleus is differing. It is drifting to another position. So because of this drift, the change in the position, there is a less weak or very less value of your bonding energy. So melting and boiling temperatures are extremely low in materials for which induced dipole bonding predominates of all possible intermolecular bonds. So that's why these are very weakest. So during these process of solidification or liquidification, as well as the melting and boiling temperatures, because of there is a lot of changes in the positions or the symmetry, unsymmetrical conditions, we are getting very less energy between them. And coming to the other category of the secondary bonding, you have polar molecular induced dipole. So what is happening here? Permanent dipole exists in some molecules by virtue of an unsymmetry arrangement. So because of that unsymmetry which is coming in the dipoles, so what is happening? So because of this unsymmetry, you can see here the positive and negative charges regions, such as the molecules which you have here, these two are not that much bond to each other. So that is one of the reason where you get the less bonding energy in terms of these induced type of dipoles. And the other category is the permanent dipole bands, van der Waals forces, which will exist between the adjacent polar molecules. So generally, what are the bonding we have? We will get through the adjacent dipoles based upon the charge, how we are arranging, or based upon the orientation of the molecules in the nucleus. Okay, so based upon this only we are trying to get the bonding between them. So the strongest secondary bonding, you can see the hydrogen bond is a special case of polar molecular bonding. So in this case only we can see the hydrogen as a strong bonding in type of secondary. Why? Because already the hydrogen is a covalently bond. So in general it is having a covalence inside. So based upon that covalence, if you arrange that another atoms of that fluorine or oxygen to hydrogen, then you can get easily good bond when compared with the secondary bond. So that's why since the hydrogen is already an existing covalent bond, so because that covalent bond we are adding some another materials from the secondary, then you're getting a strong bond in some special cases. So that type of special cases are called as a polar molecule bonding. So this polar molecule bonding is in some special cases we are trying to get with the covalency of hydrogen, then we are getting a strong bond. So these are some of the examples: HF, HO, HN. These are the single hydrogen bonds which is sharing the atoms completely to get a strong bond with the help of this hydrogen. And these are the references where you can get the what is the basic thing of the atomic structure, how the atomic structure is formed, and what are the things which are present in the atomic structure, as well as what is the importance of this atomic structure, how this atomic structure is influencing the characteristics or properties of the material, and what are the different types of bondings we have, whether it is a primary bonding or secondary bonding, and what are the energy levels or what are the bonding energies. If you want to know, you can easily refer from all these references book. First one is called the Introduction to Physical Metallurgy by Sidney Hebner, and the second one is Essential of Material Science Engineering by Donald. The third reference book you can see Material Science and Engineering by Kodigiri, and the fourth one Material Science and Engineering by William Castle. So these are the four references book where you can get the information about the atomic structure, as well as the how the nucleus and how the structure of the atoms are being arranged, and the importance of these things and the influence of the characteristics of the material, as well as the different types of bondings you have here and its subcategories. Everything you can learn from these different books. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.